Good morning, Year 5. I hope we're all well. We're going to move on and do some more maths today. So, based on looking at the work that we've done for multiplying by 10 and 100, we're going to be looking at how to multiply by 1,000 today as well. So, as normal, we're going to start off with our daily fluency. So, take some time, pause the screen, and see if you can have a go at those questions for me. Okay, let's go through some of these answers. So, number 1. Okay, we know that we can move this number sentence around, so we can do it as 10 times 10. So 10 times 10 is 100, and then 100 times 18 is 1,800. Now this one here, we have a missing gap box. We know that 95 times 10 is already 950. That means that this missing number must be 1, because 1 times 95 is already 95. What is 10 times greater than 34? We know that 10 times, that means that we've got to multiply it. Therefore, 10 times 34 is 340. 570 is 10 times greater than what number? We know that 570 is already 10 times greater, which means that this number now needs to be 10 times smaller. So we need to be dividing it by 10, and we know that if we divide that by 10, the answer is 57. Well done if you got those all correct. So on to today's learning. So here we have 1,000 block for our base 10 units. Okay, so 1,000. Here we have an additional 5, so altogether we have 6, and we have 1,000, and we have it 6 times represented through our base 10. We can write that as 6 times 1,000, so that would give us 6 thousands, so 6 lots of 1,000. We can also write it numerically, so we can write it as 6 times 1,000, which is 6,000. Based on our commutative law, we know when we multiply, we can switch those numbers around, and we can do 1,000 times 6, which is also going to be 6,000. So here we have our place value grid, okay, and this number here represented is 78. So now we're going to multiply that by 10, and we're going to watch and see what happens when we put it into our place value grid. So 78 times 10 is 780, and this is how it's represented on our place value chart. So here we can see that our 7 and our 8 values, and our 7 lots of 10s has now moved one column to the left. Let's see what happens when we multiply it by 100. So 78 times 100 we know is 7,800. Let's see what that looks like. So here it's represented, and all of our numbers have shifted yet again one column to the left. So let's have a look at what happens when we then multiply it by 1,000. Okay, 78 times 1,000 is 78,000, and here's what it looks like in a place value chart. Now we've had to add our additional column onto our place value. This is our TTH column, which is tens of thousands. So we have 78,000. We have 70 lots of tens and 8 lots of thousands. Have a think and pause the video. What stays the same with our numbers and our place value charts, and what changes? So let's see if you've noticed a pattern. So I'd like you to pause the video and have a think. Read these 3 statements, and can you find the missing number that belongs in each of those boxes based on the place value charts from the slide before? Okay, let's go through these together then. So to multiply a number by 10, each digit moves one place to the left. So when we had our 78 and we multiplied by 10, it became 780, which means our 7s moved 1 to the left to our hundreds, our 8s then moved 1 to our 10s, and then we added a 0 as our placeholder for our 1s. So let's see if you notice what happened when we multiplied it by 100. We noticed that the digits moved 2 places to the left, and we add our 0s in as placeholders into our 1s and our 10s. Same rule then applies when we multiply by 1,000. We are then moving it 3 places to the left. Now, a trick that's going to help you remember how many places we need to move that on our place value chart depends on the number of zeros that is written at the end of the number we are multiplying by. So we're multiplying by 10, it's 1 0, therefore we move it 1 place to the left, and it moves to the left because it means our number is getting bigger. When we multiply by 100, we have 2 zeros, so we know that our digits have to move 2 places to the left. And the same for 1,000. 1,000 has 3 zeros, therefore the digits must move 3 places to the left. So then let's have a look at this question. Now we can already see here that this number, okay, has already been multiplied by 1,000. So in order to work out this missing box, we need to do the inverse. So we need to do the opposite of multiplying. So we need to divide by 1000. So we need to work out what the original number is when it's made 1,000 times greater is equal to 52,000. So here is 52,000 on our place value chart. So we know if we're now doing the inverse, we have to go backwards. We have to divide. Now we know when we multiply, we're looking at our zeros. This tells us that it was multiplied 3 times. So our digits moved 3 places to the left. So now if we do the inverse, we need to move our digits 3 places to the right. So first of all, we're going to divide it by 10. So we've moved our digits once to the right. We need to move it again. We're going to move it 2 digits to the right. And now we're going to move it 3 digits to the right. So our original number that we started with must have been 52. I'd like to pause the video and have a go at these 3 questions, thinking about which direction we're going to be moving our numbers on our place value chart, and let's see if you can get the correct answers. Okay, let's go through those answers together then. So number 1, 1,000 times something is 171,000. Now we already have the greatest number, so we need to do the inverse and divide it. So we have to move our 3 digits backwards, which gives us 171. 792 times by 1,000, we're now making this number bigger by 3. So we then have the answer 792,000. Now the last one, we know from when we looked at our work from yesterday and the day before, we can rearrange this number sentence. We can have 10 times 10 times 10. So we can have 41 times 10 times 10 times 10. And we know that 10 times 10 times 10 is 1,000. So 41 times by 1,000 is 41,000. What I'd like you to do is I'd like you to now pause this video and I'd like you to have a go at questions 1 to 7 on the worksheets. Okay, let's explore this problem solving question. So a small village primary school has 22 pupils and a high school has 100 times as many pupils. So how many pupils attend the high school? So I'd like you to pause and have a think. How are we going to work out this question? I'll give you a clue. It's part of the language that's written in one of our sentences that's going to help us understand what we need to do with this question. Okay, so let's go through this together then. So we know that the village primary school has 22 pupils. We know that the high school has 100 times as many pupils. 100 times means it's got to be 100 times more. So when we are timesing something, looking at the language of times, we are multiplying. So we need to multiply 22 by 100. Okay, so 22 times 100 is 2,200 pupils. I'd like to pause the video and I'd like to have a go at these questions on your own, and then we'll come back together and we'll work through them. Okay, number 1. On Friday, a shop sells 432 sandwiches. On Saturday, the shop sells 10 times as many sandwiches. So how many sandwiches does the shop sell on Saturday? Now this is very similar to the question before. We're looking at the language here and it says 10 times as many sandwiches. This tells us we need to be multiplying our number by 10. So 432 multiplied by 10 is 4,320 sandwiches. Number 2, a baby walked 9 metres and Alex ran 9,000 metres. How much further did Alex run? So here we need to work out the difference of how we get to 9 to 9,000. Now our clue here is going to be our zeros that's going to help us. Okay, so 9 times something gives us 9,000, so we have to do the inverse. And we know that the answer is then 1,000. Our zeros here is a clue of how many times we need to move that digit. So the answer in total means that he runs 1,000 times further than the baby walks. Okay, I'd like you to now have a go at finishing off the questions on your worksheet, please.